Hi, my name is Anthony Simonet. I'm a postdoctoral associate with the Rutgers Discovery Informatics Institute, and this video is to give you a brief introduction to data science. So you may have heard of something called big data. Big data is a recent trend that we have been seeing for the last 15 years, and it's an explosion of data that comes from everywhere. One reason we are seeing this explosion of data is that data now is being produced rather by programs and machines than by people. And it is said that we are now producing every year more data than was ever produced in the course of humanity until now. Things like the Internet of Things mean that your toaster, your fridge, and your car can tweet at any moment and they can communicate with each other. All of these additional messages that go on networks mean that we need newer network infrastructure and more powerful computing services. We need more bandwidth on networks, and we need faster networks. Another trend is scientific simulations. Before, we used to do science by looking at the sky and see how the stars would move and just make observations. Now what we do is we simulate the sky. We make mathematical models of the galaxies and stars and the planets, and we just compute how they interact with each other. And this creates a massive amount of data that we need to analyze. Sensor networks are also everywhere. They are measuring the air quality, they are measuring the sun, sound, there are cameras everywhere that look at every street corner in every city. All of this data needs to be stored and analyzed. If it's not being analyzed, then it is basically worthless. And a last important source of data is social networks. If you think of it, a lot of our interactions now are electronic. It's not that we don't speak face-to-face that much, but it's more that we have a lot of private conversations using electronic devices. Imagine how researchers will look at us in 20 years or 30 years when they can just analyze the corpus of our private conversations. Until now, all of the records that we have of human knowledge is what was written in books. In a few years, researchers will be able to analyze our private conversations. So, data science, a few years ago, but it feels like a long time ago, was made about in this way. First, you had some data acquisition. So you could have a poll that you were requesting people to fill in, and that you then type in a spreadsheet. You could download files, you could download entire databases, you could download copies of emails, but all that matters is that all of this data was small enough to fit on one single machine. And you could do all of the pre-processing, filtering, removing outliers on one single machine. You would use software like SPSS, SAS, even Excel to run your analytics, and then you would produce some report. And the report would be printed out and distributed with your friend, your boss, or your community. Now it's a little different. One thing is that data cannot fit on a single computer. And when you think of Twitter, for example, there is no corpus of all the tweets. Even if there was a corpus of all the tweets, as soon as you start analyzing it, more tweets have been produced and your corpus is obsolete. Amazon probably knows at which page you're looking at, how much time you're spending on a page, how far you've been scrolling down the page until you click the back button. All of this is a massive amount of data that can be very precious if it's analyzed, or can be totally worthless if you just sit on it. Obviously, I include in data sources, social networks, and conversations over WhatsApp, iMessages, any sort of private communication, and even public transit system and connected vehicles. The process is represented as a pipe because information keeps flowing from one end to the other. And the other interesting thing is that the product at the end is not only a report, like a static report, but it's also new data. So you get a stream of data, you apply some computation, and in the end you get another stream of data that can be used in return to do some other computation. The software has evolved too. Now we don't use these expensive commercial software that used to run only on one machine, but we tend to use new free software and big data frameworks, so like Apache Spark or TensorFlow for machine learning. So now, what is big data? The very definition of big data has been debated for a long time, but let's see how we can narrow it down. So first, the volume. Big data doesn't necessarily have to be very big. Big means big enough so that the way you were doing things before doesn't work anymore. So if it doesn't fit on your computer or even on 10 computers, then it's probably big data. If it's small, but the amount of computation is so large that you need more than one processor or one computer, then it can be big data too. Then velocity, that's the second V for big data. It means that data arrives so fast that you cannot keep track of the new data, and you have to think of new ways of analyzing your data, maybe by downsampling or computing estimates instead of exact results. Variety. Data comes from different sources and in different formats. It can be text, images, or video, or anything else, and it can be structured or unstructured. What it means is that programs that need to explore different sources of data, which is very frequent, need to make sense of all of it and need to do a lot of format conversion. And the last V of big data is value. We said that big data is high value and low density, which means that it's easy to acquire. If you think of an e-commerce website and you just record every mouse movement and every mouse click, that's a lot of data, but it's worthless if you don't know how to analyze it. The value will come if you have the knowledge and the processes to actually analyze the data, and if you are able to do it before the deadline expires. Old data may not be as valuable as new data. And I would just like to talk about the software we're using at RDI2 for data science. So first, we care a lot about free software. So what is free software? Free software is free as in free of charge. You can try the software and you can use it and ditch it if it doesn't fit what you need. That's a big difference with commercial software because sometimes it's not easy to just try software and get rid of it if you don't like it. It's also possible that one software may not work for a particular project, but might work for another one. And so you might not be able to get a free license several times to try several different softwares. Another thing is freedom. Free software gives you the ability to modify the source code and adapt the software to your needs. Even if you don't know how to do that because you're not a software programmer, it's always easier to hire a programmer to modify the software for you if the software is open source. You cannot do that if the software is commercial and you don't have access to the source code. And finally, open. Open source means you can actually examine the source code and you can know what's running on your computer. And that's very important. When you think of security, you might think of passwords and you might think of encryptions, but think of all of the programs that you are running on your computers. Programs on your computers are binary code. There is no way just looking at it to know what it's doing. Looking at the source code is the only way to actually know what the software is doing. So now you may think, I don't know how to program, or I don't have time for that. I don't have the skills to look at millions of lines of codes to examine what my software is doing. But think that if the software is open source, then other people will look at the source code and do that work for you. So open source doesn't mean, and free software doesn't mean that the software is safe, but it's probably as safe as it gets. So this was the first video about data science. There will be more coming from the Rutgers Discovery Informatics Institute. Stay tuned for more videos. Thanks for watching.